Alrighty. Well, let's go ahead and get going. I think Greg will be joining shortly here. So hi, thanks everyone for joining today. I'm Chris. I'm the co-founder and CEO of CourseStack. We're a relatively new online course platform, specifically targeted and built for really technical content that requires a lot of hands-on learning elements, like virtual machines, coding workspaces, Jupyter notebooks. We're really excited to be working with the White Knight Labs team here and to be showcasing some of the awesome content they've been working on. So, John, I'll kick it off to you to kick things off and do a little intro on White Knight Labs.
Sure. Thanks, Chris. Hey guys. So if you guys don't know me, I'm John Searle, one of the founders of One Ant Labs here. And then we also have Greg Hatcher, who's one of the other owners as well. So yes, we're working with Chris and CoreStack here. Super excited. So we have some pretty unique content, right? So as everybody knows here, we have the ODPC, which is our Defensive Development Practitioner course. That's all based on malware development, kind of like using Cobalt Strike, now including Havoc. We now have some kernel content we're launching here around May 1st or the middle of the month. And it's basically all about bypassing AV right? Antivirus, all that great stuff. So what's next, right? What's the next big picture for a training program? Great question. Here we are today. So we noticed that a lot of students, right? I'm a big C++ fan, big C guy, right? I've done a lot of .NET, but if you look at all the process and injection examples across the web, it's still all based in C++, .NET, the same song and story. So our goal today is to bring you different modules for process injection around Rust, Golang, assembly, C, C++, .NET. We're going to put all the programming languages together for you and actually give you modules that take you through process injection, programming intro, all around, bypassing AV today. And that's kind of what CoreStack is. So this is, us starting in CoreStack. It's entry level all the way to advanced. We'll take you through modules. It's kind of like our own, using CoreStack as an LMS platform, which is great. And then there's also independent videos, and it's a really great platform. So we're going to demo this for you guys today. I don't think all of our languages are in Showcase today, so I don't think we have Rust ready available, but I believe we have C++, .NET. I think Golang's available. So we have the WKL team on here today as well to help showcase this. So I'm going to pass it over to who wants to go first, guys? Anybody want to go first today? Straw, you look like you want to go first. Yeah.
I can go in.
Yeah. So if you guys don't know, Strug Salva, so he's one of our lead principal engineers. He runs the Azure and cloud team for the service side and also handles, the Azure training side as well. So dude's phenomenal. He's a beast. Has a lot of cool, unique research coming out. So, give him credit. So he's pretty much wrote, with Ronick, most of our courses for cloud. It's phenomenal. So I'll pass it over to him. He'll demo some of his stuff on CourseStack and we'll go from there. So thank you.
Thank you, John. Thank you. I'll be sharing my video screen. So just give me a moment. Just let me know once my screen is visible to everyone. So I can start. Is it
Yeah,
visible?
that looks good.
Okay. Hi everyone. I'm going to demo you one of the small technique that is abdomen manager injection that we have added in our .NET malware development course in CoreStack, right? So I'm just going to give you a quick walkthrough of the code and then show you how this actually works in backend. Okay, so if you look at this code, this is a file where we have initially set up a class. The class name is my abdomen manager, wherein I am inheriting the base class that is abdomen manager. Note that abdomen manager is a class which provides us or the .NET program an isolation boundary. It provides various features like security, reliability, and it can be used for versioning and loading unloading assembly files. When you mean loading unloading assembly files, it could be exe files, it could be it could be DLL files or anything like that, right? Note, abdomen manager injection is used heavily by red teamers, malware developers, threat actors to perform various tasks that could be related to lateral movement, code executions, deploying persistence and on the target machines, right? You can turn any .NET binaries that are present on your Windows machine into a lol bin by using this specific technique. Because the base idea is that any .NET binary, you can create a config file for any of the .NET binary, and in the config file, you can map any external DLL files that you would like to load with that specific .NET program. So as soon as that particular .NET program is executed, the l- additional DLL file that you have mapped in the config file will also get loaded, which could contain malicious code. That could be anything like a shell code. It could be a stage one loader or anything like that. And it could also load a C2 server or anything that you would like to do, right? So I'm going to give you a small walkthrough. This is the first C class that we are going to use. In that, I'm using a function that is initialize a new domain. That is, this is going to create a new app domain within my program. And first thing I'm checking is the system 32-bit or 64-bit. Based on that, it is going to prompt or give a message box prompt stating that app domain x64 or app domain x86. How do I check this if the machine or the application that is going to run my DLL is 64-bit or 32-bit? That is based on the pointer size I'm checking here, right? And then we have another class that we have created, app domain ing. In this, I've written a logic which will perform a local process injection, which is a very basic technique. In this course, we are going to teach you basic concepts of each and every technique, and then you can advance that using other techniques that you learn throughout the course. Now in this, I'm doing a local process injection, but feel free to modify this particular code and perform remote process injection. Use any other techniques, like it could be APCQ injection, it could be any other new techniques that you have been exploring, writing code around, right? So in local process injection, what happens is we create a virtual memory in our current process. We allocate a memory, and then we map our shell code. We copy our shell code in that allocated virtual memory, and then we create a new thread and point that to the shell code. And that is what I'm doing here. First, I'm using virtual alloc, that is an WinAPI call within .NET. WinAPI calls within .NET, first thing that you would have to do is you'll have to import a namespace, that is using system.runtime.interop services, right? Once you do that, then you'll have to specify or use this particular syntax, that is DLL import. Specify the DLL name from where this particular when API call can be imported. Okay, so DLL, virtual alloc, your create thread, close handle, and wait for single object. All this were when API calls are present in kernel 32.dll, right? So we are importing this API calls. Then I have created some enum variables wherein we have mapped various details, like example for memory allocation, there are specific values that are needed, right? So we have created an enum mem allocation. We have that same applied for memory protection, that is mem protect, right? What are the privileges that we need for our memory? So we just need to define that. Later on, I have created a byte variable, right, which contains my shellcode. And this is a shellcode that is generated using Metasploit MSF Venom. Feel free to use any other tool, any other code to generate shellcode. That could be like .NET. You could use, there was a Python tool also available that could generate shellcodes out of any EXEs or DLL files. And then we are simply allocating virtual memory, copying our shellcode to that particular virtual memory, creating a new thread, and this just waiting for the thread execution, and it should give us a pop-up of calculator also. Now, there are multiple ways by which you can actually compile a .NET program. For this scenario, you can use an built-in utility, that is CSC, which comes within a .NET framework by default, right? That can help you to compile any .NET program into the format that we want. So we can use CSC, we can define the target type. It could be library, it could be console program, depending on the type of program that you're trying to compile. Then you define the output file name and the source file, right? In case if there are any additional third-party DLLs that you're using, leveraging within your code, then you'll also have to define a reference for those DLL while trying to compile. Now, to trigger this Abdomen Manager injection, there are ideally two ways, two approach that could be used. One, you could use config files for any .NET based program, or second, you could also set up environment variables. But note that if you set up environment variables, indeed, it would turn all the .NET binaries that are present on your machine to load that specific DLL in each and every .NET binary. Okay, to set up environment variable, this is the commands that you can run. Okay, and in case if you want to set up a config file for any of the .NET binary, in our demo, we are going to look at file history as a
Shrag,
config
this is
file.
awesome. Let's get to the platform soon, though, okay, bud? We've only got 30 minutes.
Yep, I'm just going to show the demo. I can quickly do a demo. So this is how we'll compile a code. Once we have the code compiled, we can copy the DLL file. And now I have a folder created demo. I'll just place this folder here. And now, as soon as I execute this file history.exe, this is the config file that I have created, which is open here, right? And this I have defined my assembly, that is abdomen injection, the file path where my DLL file is present, and my abdomen manager class that I had in my code. As soon as I run this file history.exe, you can see the first pop-up abdomen x64, and then it executes a shellcode that is calculator, right? So that's how we have demoed individual technique, and I'll just give you a quick platform overview. So this is the course, and this we have initially defined here the basic modules also, but this would be splitted to another course that would contain only the basic parts of .NET, which is already splitted. And then we have various other techniques that are defined in our course, like abdomen manager injection, your process injection, direct syscalls, indirect syscalls, how you can use them in .NET, right? How do you perform or write your own tools to enumerate Active Directory? How do you write your own tools to exploit various Active Directory vulnerabilities or misconfigurations? And then we are also covering a technique that could allow you to move laterally across networks by using techniques like WMA. All this, we are going to present how you can actually write your own code in .NET and perform all those actions.
Awesome. Thank you, Shrug. So if you guys, just to recap on that, so Shrug demoed a .NET module for this core stack here, and then he was demoing the platform for you guys as well, so you can see a bunch of modules. Just so you guys know, this is just the starter modules. There's actually plenty more to come. We plan to be adding more constantly, keeping this hypercurrent for you guys as well. And that's just the .NET modules. There's many others for different languages as well. So at this time, I'll go ahead and pass it over to Jordan J. He's also one of the leads for our ARTOC course as well. That's on demand and live, and he'll be demoing his side as well, so you guys can see a different version of the programming language.
And I know it says Greg Hatcher under like Jordan J's little tile. I swear his name's Jordan J.
My mistake on that one. Yeah. We also have a quick question in the chat of if there's any courses with C. I think one of them is coming up to demo that, right?
Yep.
Yeah, great. So what languages do we have? What language do we have available right now currently for?
Yeah. So I'm sorry, there was like a Zoom mistake. I kind of missed the beginning of the webinar. Right now, we're going to have .NET, specifically C# within the .NET framework. We're also going to have C assembly, and then Chris Bengtson is going to do Golang as well. So we have 4 programming languages. Everything is going live on April 30th. Basically, students can buy the bundle of all the courses together, pay a subscription price of $50 a month, and then they're off to the races. Because we created this platform because there's a huge gap right now in skill set between penetration testers that want to become red teamers and write their own tools. And I know that everyone thinks that Cursor or AI is going to save them, but it's really not. So people still need to know how to program, and because to write an LLM in the first place, you have to know programming. So sorry, I had to get off my high horse there for a second and take it away, Jordan.
Thank you very much. So yeah, as the guys said, my name is Jordan J. I'm unsure why it says Greg Hatcher underneath my name, but do not worry. So I'm going to quickly get my screen share going here. Just bear with me one sec. Hopefully everyone can see that okay.
Looks great.
Yep.
Awesome. So these will be the main courses we'll have on our initial release here. So we have .NET Programming Basics and Malware Development. And then for each language, we essentially have this kind of same structure here. So we have the same thing for assembly. In this case, we'll be focusing on the Intel AMD 64 instruction set, kind of the most common instruction set you'll be running into on your general, pen testing, red team type engagements. We'll also be looking at C, so C for programming, Malware Development, etc., as well as C++. And then we have the same kind of thing here for Golang. So in my case, I'll be covering assembly and C here, C++ also, but primarily today we'll be looking at these ones. So the main thing I really want people to be able to get out of these courses is, I don't want someone to be taking these courses and come out and essentially just regurgitate what they've seen. I don't want you to have to constantly reference back to this. I want to really make sure people have a proper understanding of what they're doing. And so that this only really ends up becoming, maybe from time to time you have to refresh your mind on something, but I want to actually add something to your skill set here. So a lot of these are very, very, if I go to the preview here. So a lot of these courses are essentially going to be very project-based. The goal for this is not only to, kind of make things interesting, right, as no one wants to essentially read a dictionary on a programming language, but also to make sure that, you really gain a true understanding and apply concepts across different areas of what you're doing. So, for example, in this case, we're getting, simple hello world, stuff like that. When we're getting into registers, we're going to make some very simple projects here. There will be extra ones, if hopefully I can kind of draw a box on the screen here. Of course, things are still being written at the minute. I need to add in those projects, but trust me on that, there will be some interesting projects. I'm going to try and make them kind of engaging. I'm going to try and avoid your typical, especially on these introductory to the language courses, I don't want to say, oh, write an address book or something, which everyone's seen 100 times, and I don't feel like people really want to do. But yeah, so that's kind of my goal here with these. And so I'll just go over the course structure quickly. I know I've got a lot to cover in just a couple minutes.
Hey, Jordan,
So
I'm just interrupting you real quick. There's a question in chat. What are the prerequisite knowledge required for this?
Oh, sorry. Yeah, let me bring chat up. So in the case of the introduction to C and assembly courses, relatively little, honestly. The main thing is for the assembly course, it would be nice if you're at least somewhat familiar with C, just to kind of help. It will just help you grasp those kind of lower level concepts a little bit easier. But if not, that's totally fine. The main thing is you will essentially need a Windows system for development, as we'll be building and targeting Windows hosts. And that's pretty much it, honestly. A willingness to try and probably make mistakes and then not smash the keyboard when it goes wrong. That's pretty much it, honestly.
Yeah, and actually, a Windows system is built into the core stack platform as well. So you actually don't even really need that because it's going to be using Guacamole for the front end. We control that VM.
Oh, okay, very nice.
Very similar to like how we run the R talking ODPC. Go ahead.
Okay, cool. So in the case of assembly, we're gonna have a quick intro, talking about what is assembly, kind of the history of it, its actual use cases in more so modern day, why you would actually sit down and write assembly rather than anything else. Then we're going to go over, kind of core concepts, so registers, control flow, etc., etc. We're going to start looking at how you can write your own procedures, also known as functions to some here, and the stack, strings and arrays, interfacing with the Windows API, how you can maybe learn to optimize your assembly. Also, maybe you don't want a 300-byte shellcode stub that's super inefficient. Maybe you can try and get that a lot shorter somehow. And then the final project here, this is just something I randomly copied just for an idea, but I'm going to be replacing this. So going back to the other courses here. So we have assembly for malware development also. In this case, I'll quickly show the C for programming basics as well, just to kind of show, again, we have a somewhat similar structure here. Essentially, we got our introduction, why you would learn C in modern day, essentially looking at, the pros and cons of C. We have a similar thing for assembly. And then, we have our development environment set up, things like that, all that good stuff. And then we're going through, similar stuff, data types, control flow functions, arrays and strings, and then, string operations, etc., etc. And then towards the end of this course, the goal is to try and get somewhat familiar with interfacing with Windows APIs and all of that good stuff. So the thing I want to kind of show off today is in the C for malware development course. So if I can bring this up here. So in this case, in tampering with telemetry, of course, there's a bunch of C examples for many of the typical malware TTPs that exist. And so I kind of want to add to that by going over a cool bug here. This will be relatively quick. Or I may be going relatively quick here, as I only have about a minute. But essentially, this is a bug on Windows 10 hosts. It's patched in Windows 11, which allows you to disable ETWTI, which is a very high fidelity telemetry source in the Windows kernel that certain XDR providers rely quite heavily on. And essentially, you can disable it fully from user mode without protected process-like privileges. And to kind of TLDR this is due to a bug with the privilege checks. As we can see right here, this may be a little small, so I'll try zooming in. Essentially, there's only a check for SE debug or SETCB privilege. There is no process protected light check at all, even though there is meant to be. And as such, kind of skipping over some of the, just typical C explanation stuff here. Essentially, what you can do is if you have SE debug, which many people may be familiar with, if you've tried maybe using Mimikatz or anything like that. If you have that privilege, essentially local admin, you can disable ETWTI and very easily blind a EDR, as some are extremely dependent on this. So this re-enables a lot of things, such as LSAS dumping. They will re-enable, your very basic process injection techniques. You won't have to do anything too crazy. It'll be genuinely extremely useful. We also go into some improvements here. As this POC, of course, it's very bare bones, right? It's a proof of concept. As we talk about some improvements, there will be some more elaboration on this as well. And then we're also going to be covering detections and preventions. And I'm going to mention this and kind of dot it throughout the course as well, as it's all good being able to write a million TTPs, but if you don't know what your actual digital footprint of, what kind of IOCs you'll be creating by using these TTPs, it becomes really hard to choose which to use when you're actually building your threat model. And yeah, I'm going to double check the chat, but I think given the time I have, that's all I can really cover for today.
Yeah, we've got one quick question. It says, I'm currently learning web application pen testing. Will it be worth learning this module now, or should I finish what I'm currently studying?
I'd say depends what your goals are. As a lot of things in InfoSec, it kind of ends up with it depends answer. If there's nothing really pressing, I would say following your interest is probably going to help learning retention. But other than that, that's all I can really say to truly kind of guide that.
Awesome.
Chris, do you want to go next, bud?
Yeah, absolutely. Let me go ahead and share screen here.
Hey, Chris Myers on the core stack side. Do we have a hard stop right at 9:30 Eastern?
No, it's 9:45, so plenty of time.
Perfect.
All right. My name is Chris Bengtson. I'm a full-time red team operator in the government and contracting space, and also do some coursework for White Knight Labs. I'm going to be covering the Golang portion for today. And what I want to talk about is a modern persistence technique that we use a lot to bypass application whitelisting, as well as a lot of antivirus and EDR products. It's really a combination of two techniques, DLL search order hijacking and DLL proxying. So basically, in Windows, when an application attempts to load a DLL, if there's not an absolute path given, it will search first in its local folder, and then there's a whole search order for where it will try to find that DLL file. What we're going to do first is go ahead and take a look at how we would determine that an application has a DLL hijack available. So I have open here process monitor from the sysinternals package. And I've just defined two very quick filters. The result is name not found, and the path ends with DLL. And what I'm going to go ahead and do is I'm going to close my Microsoft Teams here. And I'm going to reopen Microsoft Teams. Perfect. And you can see here that there's a whole series of DLLs that are search for first in the team's install folder. They're not found there, and then the search order will then progress to the system folders and ultimately find them. However, if we drop our own malicious DLL into this installation folder, we can hijack that search order and have our malicious DLL loaded into the process instead of the system DLL. So what I've gone ahead and done is I have just picked one of these almost at random here. I see that MS Teams is loading debug help.dll. And we'll start here with a proof of concept DLL. So this is just a extremely basic DLL file that actually doesn't even export any functions. We can compile this, drop this into the Teams folder. I can then run Teams, and I will receive a series of errors telling me which functions that Teams is looking for in this DLL. And then I can progressively build up a file that exports the appropriate functions. And then we end up with something like this. We can see these functions here: symbol initialize, symbol function table access, symbol from address. These are all functions that Teams is looking for within the debug help.dll. What I have done is in our initializer function, which in Golang, when you're building a DLL, is very similar to DLL main. If you're familiar with C programming for DLLs, this code will get run as the DLL is loaded into the process. So what I have done here is I have used part of the Golang Windows package to load the legitimate debug DLL. And then I'm going to inject some shell code into msteams.x when the DLL is loaded into the process. Now, the shell code I'm using here today is very simple. It's just generated by MSF Venom, which I'm sure many of you are familiar with. And it's just going to generate a message box for us, intro to Maldev, and then a little hack the planet message. So I have gone ahead and compiled this. Here's our compile string right here, making sure to use build mode C shared, which outputs the binary as a C shared binary, which on Windows will be a DLL. We can see our output name is going to be debug DLL. And we have the file right here in our folder. So what I'm going to go ahead and do is copy that over into the MS Teams directory that we found in Process Monitor. And I can go ahead and close Teams and then reopen it. And you'll see that we've successfully injected shellcode into a Microsoft signed process, bypassing application whitelisting, bypassing code signing. And this thread can live for the length of Teams. Even if we exit the thread that the message box is contained in, Teams will continue to function as normal. All right, and yeah, that wraps up the demo for today.
Chris, what are some good applications to inject into, and what would not be a good application to inject into?
Yeah, so this process, this method generally gets used for user level persistence. So you're going to want to use an application that is going to be started with pretty much any user session that something that someone's going to be consistently using when they log on their workstation. This often gets utilized when, say, that we have managed to compromise a local administrator account on the machine, and we are looking for to move laterally within the domain. So by hooking a process like this, which is going to be attached to a domain account when a user logs into the workstation, we can then move from a local account to a domain account, and then move laterally to whatever other systems that domain user has access to.
Thank you. All right, that is it for the demos on the WKL side. I just want to close with a couple things. So release date, once again, for this, all this training is going to be April 30th. So that's coming up here pretty fast. Right now, there's C#, C assembly, and Golang languages, and each of those is split into 2 different modules. So there's learn C programming basics first and then learn C for malware, because we wanted to fill a gap right now in the community where you're like thrown in the deep end and it's just malware development in C. There's a lot of LMSs out there that already do that. So cost is going to be $50 for the month for the bundle. That covers all the courses, all the languages, and we'll be adding more languages as time goes on, like Rust and Python. Going back to the question that was asked earlier in the chat, if you're learning web app penetration testing, I would highly recommend that you learn Python. A lot of our engineers use Python for web application penetration testing. C would not be a good choice for that, probably. So the name of this is going to be WKL Dev Dojo. And who is this for? This is for anyone that wants to learn programming in general and then wants to go from a penetration tester to a red teamer and start writing their own tools. So as far as the company background, because since I missed the beginning of the webinar, we are WKL. We're a boutique offensive cybersecurity consultancy that focuses on red teaming, application security, and then we also have a very mature physical access operations team. So we'll actually go and break into buildings and gain surreptitious access, impersonate employees and vendors as well. If you are going to any of the following conferences, feel free to stop by the booth and grab some swag. We'll be at NorthSec. We're teaching 4 courses at NorthSec in May. We'll be at DEF CON sponsoring the RTV again. We're teaching 3 courses at DEF CON this year. John and Jake will be at B-Sides Pittsburgh. Shirag and Ronak will be at VulnCon. And then we'll be at GurCon and CloudCon in Grand Rapids, Michigan later this year. Our current courses that we teach, either live at conferences or on demand, are RTOC, ODPC, and Shirag and Ronak's Azure course as well. So I want to thank Chris Myers and the rest of the CoreStack team for building this awesome platform. Something that's not quite ready on our end is CoreStack has the ability to create a VM, like have an AMI, and then have a guacamole front end. So all the development tools will be in that VM built into the CoreStack platform. So you won't need your own VM to do any of this. You'll be able to look at the modules and then code right next to the module as well, like watching Chris or Jordan or Shirag's videos. All right. John, you got anything?
No, man, that was good. Covered it. Beautiful.
Yep.
Well, really appreciate it, Greg, John, the whole WKL team. You've got some super deep technical courses coming out. I'm excited to see them launched and maybe try my hands. I haven't gotten hands-on hacking in a long time. So thanks for everyone who joined. I will send a follow-up after this with the recording when that's ready, as well as some other details about where you can find the course bundle and when it's launching, all that good stuff. So thanks again and take care, everyone.
Thanks, Chris. Thanks, everybody. Bye.
Bye.